we have Mirko dialing from Stuttgart, Germany, who is going to be talking about the recent EU policies and their impact on open source software. So, Mirko, all to you, and thank you so much.
Thank you. Hello to Chicago. Can you all hear me?
We can.
Okay. So thank you for the opportunity to present the recent EU policy initiatives, especially from a perspective of Linux Foundation Europe. So what I brought to you today is a general overview of the different initiatives that are currently either in the works in Brussels or already in place and are being reviewed and updated. Two highlights, the Cyber Resilience Act and the AI Act, and then like a conclusion that asks if all these policies will have the desired effect and a positive effect on the open source ecosystem. One second. So I'd like to start off with this number. This is the impact that the European open source ecosystem has on the European economy by year by year. So this is the contribution to the European Union's GDP. And as you can see, it's quite a big number. However, it's not enough just to look at the number. It's also important to see what stakeholders are developing this value, creating this value in Europe. And in the same study, one of the highlights was that the open source ecosystem has now become an integral part of ICT everywhere. Open source is in all products. It's the foundation of many of the devices that we're using day to day, of cloud, of edge, of networking infrastructure, everything. And especially in Europe, the backbone of this adoption of open source is not necessarily corporations, big, large companies, but small, medium-sized enterprises. And I'm highlighting this because, if, as you will see, in the legislation, we're pointing out that the administrative cost and the cost of compliance of the different initiatives is especially burdensome for small and medium-sized enterprises. So this is the context that we're looking at when we're talking about policy initiatives in Europe and for Europe. An ICT sector that has widely adopted open source and where innovation is to a large part driven by SMEs and open source communities. Now, Zoom is hiding my comments window. Another aspect here is that when the European Union regulates, it's not regulation that is intended only to affect the European member states. What is called the Brussels effect is the proven effect that if the European Union legislates, because it's the biggest trading bloc in the world, the rest of the world kind of feels pressure, force, or motivation, depends on how you look at it, to adopt similar or the same rules so that trading with the EU is easy. And this is called the Brussels effect. So you have a legislation like GDPR in Europe, or very successful, the legislation on handling dangerous chemicals. And because everybody, every business, every serious business needs to trade in Europe, they have no choice but to at least implement those regulations. And usually that means if they do, then they apply the same standard pretty much everywhere, because it doesn't make sense to produce products in two different ways, basically. And that's called the Brussels effect. And the Brussels effect is an underlying condition for the positive success of many of the regulations we see in Europe. Why? Because these regulations aim also at creating a level playing field across the whole industry. And this level playing field can only be achieved if you not only affect European businesses, you need to affect everybody. Because, of course, legislation always creates an administrative burden, And if that administrative burden only affects Europe, then European businesses are at a disadvantage. So it's not a accidental side effect that European Union legislation also affects the rest of the world. It is actually baked into it conceptually. Okay, so much as forward. These are the different EU policy initiatives that we feel are impacting the open source ecosystem and the software and ICT ecosystem in general. You have the Cyber Resilience Act, which is the regulation, the upcoming regulation on cybersecurity standards, the Product Liability Directive, which essentially covers defects in products and is being novelized to also cover products that are purely software. So in the past, this was mostly a directive that covered tangible physical products you could touch. And it's now basically rewritten to cover all sorts of products, including software. We have a framework on standard essential patents, which, for example, introduces the requirement for an essential database of essentiality, where you have to declare if you consider a patent that you hold to be a standard essential patent. We have the AI Act, that's one of the highlights I will give today. With the Data Act that deals with how businesses treat data. It's less about software systems and more about the people operating them. But it includes requirements like that software systems have to be designed to protect data. They can accidentally leak data. And then we have the Electronic Identification, Authentication, and Trust Services Regulation, EIDAS, which deals with identity, not just for people, but also for applications in the browser, which is also a current topic of debate. So as you can see, there's a wide spectrum of initiatives. And since innovation today in almost all sectors is driven a lot by software, every regulation on the software industry affects, well, pretty much every product that we use. And since every product is built on an open source foundation, if you impact the open source ecosystem with your legislative initiatives, then you're also impacting basically the whole ICT market. Okay. So first highlight of currently ongoing EU initiatives is the Cyber Resilience Act. To start with, the Cyber Resilience Act contains only goals, policy goals, that we will probably all support. Nobody disagrees with that. So, for example, the policy goals of the Cyber Resilience Act are to reduce vulnerabilities in digital products, to ensure cybersecurity is maintained throughout the product's lifecycle, and to enable users, consumers, to make informed decisions when they select and buy products. Especially bullet number 2, is one that has probably bugged many of us, that you buy a device, and after a short period of time, maybe less than a year or two, the manufacturer of the device stops making software updates. Now, you could probably live with the device not gaining new functionality, but if you are aware that there's a security issue with the device and it's not being fixed, then you will probably retire the device and buy a new one. And that's something that the Cyber Resilience Act addresses. Also, the last one, I think, is a very laudable goal. It's to, through mandatory documentation, through certification and other means, making sure that users know what they're getting when they're buying something. So that's the what. The what is absolutely great. The how is slightly more controversial, because maybe one thing I need to add here is that all the regulation that we're talking about is anchored in maintaining and controlling access to the European Union internal market. So basically it says, if you bring a product to the market, you need to be compliant with all these legislations. And that's why the concept of making products available is so important and so essential to many EU laws and acts and regulations. And the Cyber Resilience Act defines, kind of redefines, making a digital product available, it speaks of digital products, which include software, hardware, and combinations of the two. So it redefines making products available as the first distribution of the software so that it can be used in the market. And everybody who comes with an open source or free software background would immediately raise their eyebrows and says, first distribution. First distribution is what the original author of a piece of open source software does when they make the release available on GitHub. Because, of course, we talk about distribution when we say, under an open source license, I make the software available for everybody to use, modify, study, and redistribute. So it's even called the Linux distribution. And this is not a mistake. This is an intended concept. And we, of course, say, well, it shouldn't be the upstream community that makes a product available for first distribution after they developed it, that is then responsible for cybersecurity vulnerabilities in downstream products. There's another difficulty, and that is that the obligations are not limited to the intended or advertised use of the product. So basically, every vulnerability that is found in any way of using the product is something that the manufacturer, the person that makes the product available, is responsible for. And the last one is that depending on the criticality of the product, I will get into that in a bit, there are certain levels or different levels of required certification. And for critical products, we get into mandatory third-party certification. Now, this would be fine if critical products are commercial products. But there's an appendix in the current draft of the CRA, in the original one, that lists as critical products things like container runtimes and hypervisors, which are clearly open source technologies. So if that is applied in a strict sense, then open source communities need to provide third-party certification for their software releases, which of course costs money and is probably beyond the means of many of the projects we're talking about. So this is we talk about the CRA. The most important thing probably is to know what does it try to achieve and what are the key approaches to it. And that's what I try to explain here. So under the Cyber Resilience Act, everybody who places digital products in the European market will be responsible for these things. You need to fix discovered vulnerabilities. You need to update software, provide software updates across the lifecycle of the product, and you need to audit and certify the products. And these responsibilities are borne by people that first make the product available for distribution, which is not necessarily the downstream user integrator, but potentially the upstream open source community. Who's responsible under the CRA? That's staggered, and we try to assess it, but there's actually a lot of ambiguity here because of a kind of vague circumscription of what an open source community is, essentially. So an individual developer is probably excluded. So somebody who contributes as a volunteer in their spare time will never have to comply with the CRA. However, there's a fine and blurry line between being a volunteer hobbyist developer and somebody who, for example, accepts donations or small bounties. So as soon as your behavior is considered commercial, you're not considered an individual volunteer developer anymore. Also, the CRA qualifies this all with non-commercial, but it doesn't say, for example, that non-profit means the same as non-commercial. So non-profit foundations, like the Linux Foundation, that are developing and releasing open source software need to comply with the CRA. And private companies always need to comply with the CRA. That's probably also not controversial. What makes this difficult is that until now, the CRA does not distinguish between open source and closed source software. It basically talks of digital products. It has an exception that excludes non-commercial open source development from the coverage of the CRA. But other than that, it doesn't qualify the products as open or closed. There are two, I would label that as misconceptions in the draft of the CRA that make it so complicated or controversial. One is the assumption that the developers who basically know the code of the product the best and can fix security vulnerabilities are working in the upstream projects. And we tried to explain repeatedly that upstream is where code contributions end up, but the developers don't work upstream. They work downstream in businesses, in people making product, companies making products. They find improvements and bug fixes as part of their work and contribute that back upstream. So there's no upstream community in most places that is able to fix all the code and to assess security vulnerability because the open source community is decentralized. And the other misconception is that these obligations are all manageable because open source foundations are large, well-funded funds for big tech businesses. And that's a dangerous assumption. There are probably open source communities that are organized by large corporations and probably are able to gain the funds necessary for that. But I would say there's a very small share of the open source community that consists of small volunteer-driven groups, part-time maintainers, people who developed a NPM module because it's interesting to them, but if they are really required to fulfill security requirements like certifications, they will just probably stop developing that. And this misconception is also difficult to communicate in Brussels because it's like the open source community in its decentralized way. It's hard to grasp. It's also hard to point to the value that this community creates if it's difficult, if they're not represented by big organizations. So one really conceptual issue that I personally have with the idea that software vulnerabilities need to be fixed upstream first is that a vulnerability is not something that usually manifests itself only in software. If you ask somebody to describe a vulnerability, they will have to tell you, if I run this software version on this hardware environment, and the system is configured to allow me, for example, to use a keyboard to log into the system, then I can do this and I can gain root access. But you cannot describe this without saying what is the system configuration, for example, that could disable this access immediately, or on what hardware does this run, and what software version. This is something that goes back to Turing and describes how you explain what a computer does in a certain situation. And the COA basically only looks at the software, or it looks at the vulnerability and then goes upstream and says, need to fix this. But upstream doesn't necessarily know the downstream use case, configuration, or hardware. And it also doesn't necessarily have the hardware configuration available to verify that the bug is really fixed. So this idea that you can take a vulnerability out of the concept of a context of a concrete product and place the responsibility of fixing the vulnerability upstream, where the software is provided for anybody to use for any purpose, is a theoretical impossibility, I would say. And this is why we'd expect really difficulty and real difficulty in the implementation. There's some other concerns that many people have raised. There are trust issues. There's a requirement in the COA that actively exploited vulnerabilities need to be reported to an authority within 24 hours. Currently, the expectation is that this is ENISA, the European Network and Information Systems Security Agency, but there is a debate that this needs to be done in every member state. Then you have 27 local security agencies, and you have to trust all of them 100% because you have to disclose vulnerabilities even if no fix is available. There's a risk that communities that find themselves unable to comply with that will impose download filters and say that you have to go through a commercial intermediary to get the software because we're not making it available in Europe because we don't want to be responsible for it. There's a regulatory burden. The overhead of acquiring certification, of doing constant security audits, etc. This is all necessary work, but it costs money. And usually the effect of a higher administrative burden and a higher administrative cost is concentration in the market. So basically, your ecosystem that, as I described, is characterized by small, medium-sized companies will start to concentrate or be bought up. Now we know that big tech is rarely headquartered in Europe, and big tech is usually who buys small, medium-sized companies when they get successful or into trouble. So this is not something that necessarily benefits the European Union. And of course, yes, this exporting of regulatory requirements works, but there's a difference when you're an EU, say, software startup or a small community that starts to build commercial work around their open source software. In Europe, you will have to be compliant with the CRA from the start. Outside of Europe, you can experiment as an open source community for as long as you want, as long as you're not importing the software into the European Union. So you can have a long period of low administrative overhead until your product is ready, then you certify it and export it to Europe. In Europe, that's not possible. As soon as you're acting commercially, you have to be compliant. And this may be a disadvantage for European businesses. So in sum, the Cyber Resilience Act relies heavily on the Brussels effect that I described. And there's a question here. The open source ecosystem isn't necessarily a market. The open source ecosystem is a commons, a collection of public goods that is available for free. And for the open source ecosystem to work, it doesn't require access to the European internal market. It could simply ignore it. And that's why we're not sure if the Brussels effect, as it works on other legislation, works on the open source commons. And that's why I mentioned earlier, for the legislative initiatives of the EU to work, it is kind of necessary that these regulations are also exported. And that's very questionable with the CRA. So we expect additional burdens for SMEs, comparatively to large business. It's a higher burden. Sorry. We expect that the CRA disincentivizes upstream first development. Why? Because you're responsible for what you contribute upstream, and then the communities are responsible for what they release. So it's actually more beneficial in this setup to work on an internal fork and keep your patches for yourself. And because it makes it places this administrative burden on European businesses first, it encourages offshoring of development to other areas, other regions. So there's not necessarily a huge endorsement of the CRA, which is a qualified, not great endorsement, because as I said, the policy goals are very much supported by everybody. It's the how, and maybe one encouraging sign is that almost all of the discussions on updates to the Cyber Resilience Act in the legislative process now deal with this open source exception, the integration of the Cyber Resilience Act conceptually into the overall ecosystem, and into making it work without like shooting the open source community in the foot. So we do see that the European Union is reacting to the feedback and considering to change the CRA draft before it gets enacted. However, it's a very intransparent process, and there are lots of amendments tabled and suggested for integration, and we don't know which one will pass. The process is currently ongoing, and it's a bit of a surprise bag. So everything I explained to you today is based on the draft of the Cyber Resilience Act that is the foundation for the discussion, not on the amendments necessarily. What do we think should be done to fix it? We think that the responsibilities and obligations must be aligned with the structure of the supply chain, which means if you provide a product as is with no warranties, then you shouldn't be responsible under the CRA. As soon as you take this and integrate it piece by piece into a commercial product that you then offer to your consumers, you're responsible for what you integrated for that to work and be secure. If that would be the case, much of the CRA would work much better. But as I explained, currently it pushes the obligations too far up the stream, potentially all the way to the open source communities. And that in turn is the second suggestion here, would mean that the commercial entity that places a product on the market, not the one that makes it initially available for distribution, must bear the responsibility under the CRA. So much for the CA. I would like to move on quickly to the AI Act. Similarly here, the policy objectives of the AI Act are not questionable. Everybody agrees with them as well. The objectives are AI systems placed in the EU market should be safe and respect EU law. The regulation should work in a way that facilitates investments and innovation. It should enable, first of all, and then enhance governance and effective enforcement of EU law in systems with AI. This includes fundamental rights and human rights and others. And it should facilitate the development of the single market. Many of the EU legislations are aimed at that, at further developing the EU market. To achieve that, the AI Act implements a risk-based approach. It basically starts with lower minimum risk, where it does not apply any obligations to the operator of the system. And then it goes up. Limited risk, like chatbots. There needs to be transparency. You need to declare how the system works and what it does. For higher risk systems, like systems for biometric identification, like your fingerprint scanner, you need to have an ex-ante beforehand conformity assessment of the system. And that all needs to be published, and etc. And there's interestingly a fourth group, which is unacceptable risk. So systems that, for example, exploit vulnerable groups can be used to implement human rights violations, and others are not allowed, basically, to operate and to bring into the European market. So far, everything you heard about AI Act is about the application of AI. It doesn't talk about what is the software that you run. It says, what is the application? How risky is the application? And then you have certain obligations under it. How is that enforced? The member states of the EU will have to set up national supervisory authorities, and the EU will set up an European Artificial Intelligence Board that coordinates the work. For high-risk systems, the member states will assess the compliance. This may require that you disclose the source code and the data of the system to the national government. And then there are corrective measures. For example, you can be forced to withdraw or recall the system. As usual, this is supported by the possibility of fines in case of non-compliance. So what do people think about the AI Act? Overall, the approach of focusing on the applications and to classify the applications according to risk is relatively widely supported. The discussions are more on the details, like the definitions are too broad, like technically, the way the AI Act describes AI covers sorting algorithms, because they're also very smart. There's a certain regulatory overreach, like it extends to low-risk systems, etc., etc. One of the key debates is, should the AI Act focus on the impact or the technology? So everything I explained was application. That means the impact of the use of the system. If the impact of the use of the system is risky, more risky, or really highly risky, or totally unacceptable, then based on that, the technology is regulated. But there are clauses in there, especially as you will see in a minute, in the suggested amendments, that also extend to the technology and say foundational AI models that can be trained for different use cases and kind of provide building blocks should also be covered, even though they're not applications yet. Other concerns are that it's difficult for consumers to actually enforce their rights, to claim them, and that the regulatory power of the European Union is to a good part delegated to European standards development organizations, who are developing the standards that the acts refer to as, if you follow these standards, you're compliant. Where are we in the legislative process of the AI Act? The trilogues, the last stage of lawmaking in the EU, have already begun. The Council, the European member state representation, recommends a narrowing of the definition so that it doesn't cover sorting algorithms anymore. But it also suggests covering general purpose and AI foundations models. And that is where we are really concerned, because that's about the technology, including many of those are open source, as opposed to the application. Yeah. This is it about the AI Act. I have a little bit of an outlook, and then I'm done, so I will almost be done on time, Anna. So how will the open source community react to all of that? The first aspect is we really need to get organized, because clearly we are now in the focus of regulators. The open source community is the only innovation driver and technology knowledge transfer system that is not regulated at all, or not much. So this will not be something that we can wiggle out of. We will have to deal with this. This means that we need to professionalize maintenance and the responsiveness to vulnerabilities further. We're already good at that. And there will be stricter requirements to what open source governance actually means. It is already visible in the AI and the CRA, that certain forms of open source governance will be less encouraged or under more obligations than others. And we should forget that we can ask for an exception. The CRA already says only non-commercial open source development is excluded, which is a very small share of the open source ecosystem. And as I said, we're an integral part of the ICT ecosystem, so we will not be able to remain unregulated, which means we need to really build an approach, we meaning the ecosystem, but also lawmakers, to regulate ICT overall, the ICT ecosystem, so that open source thrives and continues to build the foundation of the technologies, of the products. But yeah, we have to be compliant with the upcoming regulation as well. And yeah, last slide. All these obligations that I've explained mean that maintenance of open source projects that you use in your products is becoming a corporate responsibility. You will be responsible for maintaining the software, for fixing vulnerabilities in the upstream code that you use, if you bring products into the market, which is a key driver to understand where on the open source journey your business is, and where you need to mature further in that approach, so that you can engage with the upstream communities that whose products, software you integrate into your products. This is a really important point, and that's why I'm ending here. Thank you very much. And I hope we have time for questions. And there are questions. Thanks for listening.